present video we will discuss the one example problem on forecasting method. Let's see the problem. A contractor's record during the last 5 weeks indicates the following number of job requests. Predict the number of requests for week 6 using each of the following methods. So A is naive method, B a 3-year moving average method, C is the exponential smoothing with alpha equal to the 0.30. Use 20 per week second forecast. So let's see the solution. So first we have to go for the naive method. The naive forecasting method assumes that the forecast for the next period will be equal to the demand in the most recent period. So f of t plus 1 equal to the dt, where f of t plus 1 equal to the forecast for next period and dt equal to the actual value of current period. So then first I have to apply the naive method. So and we know that in the naive method f of t plus 1 equal to the dt. So here I have to determine the number of requests for the 6th week. Then f of t plus 1 equal to the 6, then which is equal to the d5, mean forecasting value of the 6th week which is equal to the actual demand of the 5th week, that is the 22. Next we will move to the simple moving average with the 3-year moving average. So we know the formula for the simple moving average, f of t equal to the dt minus 1 plus dt minus 2 plus dt minus 3 up to the dt minus n divided by n. So here it is given the 3-year moving average. So we have to consider the only last 3 years demand data only we have to consider. And we have to determine the 6th week forecasted value we have to determine, that is the f6. So f6 equal to the d5 plus d4 plus d3 divided by 3, which is equal to the 20.33. So next we will move to the exponential smoothing method, and here alpha value is given the 0.3 and use 20 for the second week forecast. So let's consider f2 value is given the 20. And we know the formula in the exponential smoothing method, ft equal to the ft minus 1 plus alpha into dt minus 1 minus ft minus 1. So here I have to determine the forecasted value of the 6th week. So that is the f6. So f6 equal to the f5 plus alpha into d5 minus f5. But we don't know the f5 value. So in this regard, first we have to determine the all the forecasted values for the each week. So first write down the given data is the week wise its request, or let's consider the actual demand. So let's consider d1 equal to the 20 and the d2 is the 22 and d3 is the 18 and d4 is the 21 and d5 is the 22. And moreover it is given the f2 value is the 20, and we know that the f1 forecasted value in the first one which is equal to the d1 demand, actual demand of the first one. So write down here data. So f1 which is equal to the d1 and f2 value is given the 20. Then we have to determine the f3, f4, f5. Then we have to determine the f6. So first we have to determine the forecast of the 3rd week. So f3. So f3 equal to the f2 plus alpha into d2 minus f2. So here f2 value is the 20 and alpha value is the 0.3 and D2 value is the 22. Then substitute here. So we will get the F3 value is the 20.6. So next we determine the F4 value, forecast of the 4th week. F4 equal to the F3 plus alpha into D3 minus F3. So F3 value we know, D3 value we know, alpha value we know. So F3 value is 20.6, D3 value is the 18, alpha value is the 0.3. Substitute. So we will get the F4 value is 19.82. Similarly, we have to determine the F5 value, forecast of the 5th week. F5 equal to the F4 plus alpha into D4 minus F4. So F4 value we calculated 19.82. D4 value is given in the data 21. Alpha value is the 0.3. Then substitute. We will get the F5 value is the 20.174. So we got the F5 value. Then we have to move to the next. We will go to the forecast of the 6th week, F6 value. F6 equal to the F5 plus alpha into D5 minus F5. So we know the F5 value 20.174 and D5 value is the 22. Then substitute. We will get the F6 value is 20.7218. So this is the final solution from the Naïve method. 6th week forecasting value is the 22 and 3-year moving average method. So F6 value is the 20.33 and exponential smoothing method F6 value is 20.7218. So this is the solution and thank you.